Okay, looking at our properties of logarithms, our first one we're going to look at is the product property. Product property of logarithms. And this one says that if I have the log base x of a times b, that is equal to the log base x of a plus the log base x of b. Remembering that x is not equal to 1. So looking at an example that we use with this, we would, as an example here, I have the log base 4 of 192. I need to evaluate what this value would actually be. Well, I can use my product property to help simplify this. The log of this becomes the log base 4 of 4 to the third power times 3. This 4 to the third power is 64, and 64 times 3 is 192. I can then use my product property up here and say this is going to be the log base 4 of 4 to the third power plus log base 4 of 3 . I can then go and rewrite using property here. It says 3 log base 4 of 4 plus the log base 4 of 3. Now with logs, anytime that your base and this number here are the same, they essentially cancel each other out. So therefore I'm left now with 3 plus the log base 4 of 3. So now if I'm told that the log base 4 of 3 is approximately 0.7925, I can substitute that in and see that 3 plus 0.7925, and I actually get a nice approximate answer here of 3.7925. Let's look at another example like this one. Here, I am given the log base 4 of 2 is equal to 0.5. And we need to approximate the log base 4 of 32. So I come down here and say the log base 4 of 32, that would be equal to the log base 4 of 2 to the 5th power. My exponent here can come out front of my log now. That becomes 5 log base 4 of 2. This right here is what I was given right here. So I now have 5 times 0.5, and then half of 5 would be 2.5. Okay, so next we're going to look at our quotient, the property of logs. Our quotient property says that if I have log of base x of a divided by b, that is equal to the log base x of a minus the log base x of b. Whereas with multiplying, we were adding them. For division, you subtract them. One of the ways they'll give us problems for these, and here's some examples here. So they're going to go through and they're going to tell us that we have log base 4 of 2 is equal to 0.5. The log base 4 of 3 is approximately 0.7925. And then they would give us a problem like this. Says find the log base 4 of 4 over 3. Well, I can rewrite this using my quotient property. It would say I have the log base 4 of 4 minus the log base 4 of 3. Well, the 4 is not going to work for me because I don't have anything that goes with that, but I can change this to the log base 4 of 2 to the second power. Or if I did remember, hey, if I have log base 4 and a 4 there, those things are the same as 1. So I could do this right here, or I could take and do this one. Either way, we're going to get 1 in the leading spot. Now the log base 4 of 3, this is the information that I am given right here. So I now know that that one's going to be 0.7925. Supposing I did forget that log base 4 of 4 is 1, and I went through and worked it out like this, I would have 2 log base 4 of 2 minus my 0.79925. Then I would have 2 times 0.5 minus 0.7925, which this still comes out to be 1 minus 0.7925. And whenever you go through and do your subtraction, you get 0.2075. And that's the equivalent of log base 4 of 4/3. Our last property we're going to look at is our power property. We've already talked a little bit and done a little bit with our power property. Our power property, if I can spell property today, it says that if I have the log base x of m to the power p, that is just equal to p times the log base x of m. Our exponent moves in front of our log. So an example here,